Today we are looking at how to graph exponential functions. We're going to use our calculator a lot. You'll cut out this foldable, leaving a little bit on top and on bottom because we're going to add something to it. A new word that we're going to use is called asymptote. So I want you to look at your unit divider for unit 8. Asymptote is a line that is approached and may or may not be crossed. So remember how our exponential functions will do this? The asymptote for an exponential function is a line, the horizontal line on this, that it never actually touches. Remember I talked about how the function, the graph, it skates along that the x-axis, but it never actually touches. So it's going to just skate along it without actually touching it. It gets closer and closer and closer without actually touching it. We are going to talk about it being y equals some number. So if it's the x-axis, it's going to be, so x-axis is going to be as y equals 0. Most of the functions that we've done so far, the asymptote is at y equals 0. So it's an equation, y equals some number. Whatever number it's approaching, but never actually touching. Okay, the other things that we are going to look at whenever we graph is domain. So do y'all remember domain and range? Domain is a set of all input, which is our x values. Man, that pink is loud, right? It's hard to see. Anyway, the domain is x values. And then the range, do you remember what values the range is? The y values. And then our last thing is horizontal asymptote. Horizontal line approached by the curve as the function approaches positive or negative infinity. Horizontal asymptotes may be crossed by the curve. It's going to be y equals some number. It's a horizontal line, so it's going to be y equals some number. All right, so let's go ahead and look at our functions that we're going to graph. First one is 3 raised to the x value. So we're asked to do the table for this. So let's go ahead and just plug in the number. So 3 to the negative 2, 3 to the negative 1, 3 to the 0, 3 to the first power, 3 to the second power. So let's remember what our rules are. Anytime you have a negative exponent, do y'all remember what we do? You put it on the bottom. So this would be like 1 over 3 squared. Hopefully you remember that. Which would be 1/9. But because we are going to put in the calculator, let's go ahead and do 1/9. So it'd be 0.111. So it's repeating. 3 to the negative 1 means 1 over 3 to the first power, which is just 1/3, so it's 0.3 repeating. What's anything to the 0 power? Are you sure? It's itself. Oh, no. Mm-mm. It's just 1. Three to the first is 3. 3 squared is 9. So now we need to plot the coordinates. So these are all going by 1s. So we'll start with our y-intercept. 0, 1. 1, 3, 2, 9. That's part of the graph. We'll go to the negative. So negative 1 is at 0.3 repeating, a third. Negative 2 is 0.1 repeating. That is going to be where your asymptote is. Because no matter what I put in, so let's say I do 3 raised to the negative 10. Let's say I go far enough. Do y'all know what this means? The e to the negative 5? It means I would move the decimal over 5 places and put a 0 there. So it's getting closer and closer to 0 without actually ever touching. 3 raised to the negative 5. See that number 0.004? So let's go ahead and have the function be skating along that x-axis and then growing rapidly. And use a highlighter to draw the asymptote. So grab a highlighter. There should be one in there. The asymptote is the x-axis on this one. It's never going to touch it. It's just going to get closer and closer and closer without actually ever touching it. All right, so let's go ahead and identify a couple things. Y-intercept, where does it cross the y-axis? 0, 1. The domain is all the x values. The x is going to go to the left to infinity because it's going to the left to negative infinity and to the right to positive infinity because this is going to keep on getting further and further to the right. So when your domain is negative infinity to positive infinity, it can be represented by the term all real numbers. So x can be anything. There's no break in that. But the range isn't, because what's the lowest it'll go? This asymptote is kind of like where it stops. So it's at 0, but then it's going to go on and on to positive infinity. So our asymptote is y is greater than 0. You could do 0 to negative to positive infinity as well. So we've done domain and range with inequalities and with intervals. So you can do it either way. I think I'm going to stick with the inequalities. And then our last thing is the asymptote. I'm going to spell it for you. A-S-Y-M-P-T-O-T-E. The asymptote is that highlighted line that we did. So it's at 0. So it's going to be y equals 0. We can do this all in the calculator too. I just wanted to remind y'all about a couple of things with exponents. So we can go ahead and put this in 3 raised to the x. I want everybody to put in the function 3 raised to the x. And then look at the table and just make sure we did it correctly. So look at the -2 is 0.111, -1.3 repeating, and then the pattern is 1, 3, 9, 27, 81, 2, 43. What is the rate that's being multiplied by?
3.
Yep, just 3. All right, go ahead and do the next one. One-third raised to the x. I'm going to just go ahead and put it in the calculator. I think that'll be fun. Once you put it into y equals, make sure you make the x an exponent. Then copy down the table for those values. Yeah, it would be 1/3 to the -2. 1/3 to the -1. 1/3 to the 0. 1/3 to the first. 1/3 to the second. This would be 9, 3, 1, 1/3. 1/9. What's that going to be as a decimal? Because we need to be able to graph it. Yeah. 0.111. 1/3. 0.3 repeating. So if you need to, you can go over here and put in 1/9 to find it as a decimal once you get it. So go ahead and graph it. So -2 to the 9, or equals 9. -2, 2, 4, 6, 8, 9. -1, 3. Did I do this right? Yeah. Okay, and then 0, 1, then 1/3, and 0.1. Go ahead and make your exponential curve. Put your arrows on the end, showing that's going to continue on and on. Now we're going to identify where the asymptote is. What's the line that it's going to skate along without actually going over? The x-axis. And then answer the questions. What's the y-intercept? 0, 1. The domain, how far left and how far right will it go? Negative infinity to positive infinity. So that's all real numbers. And then the range. How far down will it go? 0. And then how far up will it go? So y is greater than 0. And the last thing, the asymptote. So we're at the word asymptote down there. And so what's the equation for the asymptote? Yep, it's just y equals 0. Okay, we're going to skip a couple of these. We're not going to do this one or this one. Two on the left, yeah. We're going to do the 2 on the right. Okay. So what do you notice about this equation right here? What's different about it? Plus 1. That's going to change the y-intercept. So let's go ahead and, well, we can just use our calculator. So 3 raised to the x, and then get out from that exponent. Everybody put this in the calculator. Plus 1. Then go to the table of values. So the first one is 1.11 repeating. Second one is 1.3 repeating. 0 matches with 2. 1 matches with 4. And 2 with 10. Let's go ahead and graph it. So -2, 1.1 repeating. So it's -2 and up 1, just a little bit over 1. -1, 1.3 repeating. 0, 2, 1, 4. Yeah, 2, 10 won't fit, but it's just 1 above, right? Because it's 9, and then we can go up to 10. We can put it on there. What is it going to get closer and closer to without touching? 0's here. Is it going to get that close? Where does it start just decrease? Yeah, +1. So let's go up, up, like that. So the asymptote is at +1. That shows up in our equation right here. Previously, we didn't have any plus or minus, so it was 0. So we're going to write it here. So the y-intercept is 0, 2. Domain, how far left is it going to go? To positive infinity, yep. So our domain is all real numbers. Our range, though, how low does it go? 1. up to infinity because it's continuing on. So y has to be greater than 1 here. In our asymptote, yep, y equals 1. See how these are almost the same? The asymptote is at that number. The range has to be above that number. Okay, the last example we're going to do is this one. Go ahead and plug it in your calculator. I think this point was a reflection of that. So let's put this in. 1 over 3 raised to the x minus 1. Oh, that's really hard to see. So we got 8, 2, 0, negative 2/3, and negative 8 over 9. So we have some fractions here we need to convert to decimals. Negative 2 over, negative 2/3, 0.6 repeating. Oh, it's a negative. Negative 0.6 repeating. And then negative 8 over 9, negative 0.8 repeating. So we'll plot those points. Negative 2, 8. Negative 1, 2. 0, 0. 1 negative 0.6. So it's going to be closer to negative 1. And then 2, negative 0.8. It's going to get closer to negative 1. Where's the asymptote going to be at? Negative 1. The y-intercept, where does it cross the y-axis? 0, 0. Domain is left and right on the x-axis. Negative infinity to positive infinity, because it's going left forever, right forever. There's no boundary on that. So all real numbers. What about the range? How far down will it go? Negative 1. Y is greater than negative 1. Yep. Y equals negative 1 is our asymptote. Yep. Glue this in your journal on the next page. I'm going to pass out your assignment.